These are called positive catalyst, and those who retard the rate of reaction we call them as negative catalyst. Now, we find that we also suppose you want to speed up the activity of the catalyst. In that case, there are some substances are added to expedite the role of the catalyst. In this case, along with the catalyst, we also add some substances to increase the efficiency of a catalyst, and these are called promoters. Okay, these are, you can add it, but in nature also will find, when you talk about this natural catalyst, you'll find in the nature also they provide something like that. So we call them as promoter, or we call them as activator. And some cases we find this excess efficiency of a catalyst also found to be little detrimental for the chemical reaction. In that case, we try to slow down the catalyst after a certain step, or do not want that after a certain step the catalyst will further react, because it will be a multi-step reaction. If you wish that it should expedite the process of the first step and you do not want the second step, in that cases, some substances are added by which the catalysts are totally being deactivated, and these are known as catalytic poison. We are the catalytic poison. These examples we are going to study when we go for organic chemistry. Okay. So now, classification of catalyst. Initially, whatever I had told you is about the definitions. Classification of catalyst. So catalysts can be classified into two categories. One is called homogeneous catalyst, and second one is called heterogeneous catalyst. Okay. So you have homogeneous catalysis, and second one is called heterogeneous catalysis. Heterogeneous. Now, what is the homogeneous catalyst? When you find the physical state or the phase of the catalyst is same as that of the reactants and products. When the physical state or you know, right, phase of the catalyst is same as that of reactants and products. Then these are called homogeneous catalyst. Homogeneous catalyst. Okay, and the phenomenon is known as ND. Phenomenon is known as homogeneous. Okay, please remember we have very few homogeneous catalysts. So in that case, for examination purpose, it is important, and please try to remember their name. Few of the examples you are supposed to learn. See, you might have studied the manufacture of sulfuric acid from sulfur dioxide. If those who have come from state board, they might not have studied, but those who have come from the ICSE, they have already studied. Okay. So in that case, what happens? The sulfur dioxide gas is being oxidized. Okay. By atmospheric oxygen. All right. I'm talking not of the recent one. Recent one we are using heterogeneous catalyst, but the original process was called, that is called lead chamber process. So in that case, sulfur dioxide is very difficult to oxide. You require a catalyst. So in this case, we have used nitric oxide gas to oxide. See here. This is gaseous, this is gaseous, this is also gaseous, this is also gaseous. So these are called, this nitric oxide is a homogeneous catalyst. Now let us go for another example. This is called hydrolysis of esters. Suppose I have taken here ethyl. Ethyl is liquid, yes. And here we are taking water as a reagent as well as a solvent. So it breaks up to give you, it undergoes hydrolysis, water reacts, and you get here acetic acid, that is also liquid, and you get ethanol, this is also liquid. Okay, so in this case we use aqueous mineral acid. See here. This is also an example of homogeneous catalyst. Okay. Now, similarly, if you go for hydrolysis of sugar, see sugar formula, you know, C12 H22 O, which is called sucrose. Sucrose, when it undergoes aqueous solution, right here now, aqueous solution, so that is also liquid. Water, it gives us, that all of you know it, it gives us equal amount of mixture of what? Glucose and fructose. Formula is same, but the structures are different. So here also we use dilute mineral acid in the form of hydrochloric acid or sulfuric acid. So these are the examples of homogeneous catalyst. Now I need not tell you the definition of heterogeneous catalyst. By the name itself, you know, when you find that the phase or the physical state of the catalyst is different from the reactants and products, these are called heterogeneous catalyst, and the process is known as heterogeneous catalysis. Okay. So I'll write down the examples. I don't know, this ink is different and it does not go from the board. It's very strange. What to do? It goes something, I think the board also has board. At this moment, I cannot change this board also. What are the examples of these heterogeneous catalysts? Heterogeneous catalyst. That you know, plenty of things you know. First one that you have studied in your school was first example of catalyst that you got it in the school is the decomposition of potassium chloride by which we prepare oxygen. So this is solid. Okay. It gives you potassium chloride, that is also solid. But mind you, product is oxygen gas. Okay. So right here now, sorry. 6 and this is 3. Here we use, this is the first example of the catalyst that you have come across in your life. Then there are some famous reactions are there. Maybe that one some of you have already studied in school. This is the famous Haber's process. Hmm? See, nitrogen gas, hydrogen gas in the ratio 1:3. When you heat it, in presence of catalyst, you get ammonia. Now, what catalyst is being used here? Iron. You know, iron is a solid. Okay. Now, contact process. Contact process is being used for the manufacture of sulfuric acid. Just now I have done, this is the example which you can little bit see. Huh? Huh? I told you the new process is contact process, where what is being done here? Here, this sulfur dioxide gas is being oxidized by the atmospheric oxygen to sulfur trioxide gas by using vanadium pentoxide. This is the white powder. Then all these things you are going to study in your this thing this year in your syllabus. All these things. Oswald process. In Oswald process, we manufacture a nitric acid. In this case, ammonia gas is being partially oxidized by atmospheric oxygen to nitric oxide, and at high temperature when you do, so this also comes out in the form of vapor. And here we are using platinum and rhodium. Both of them are solid. So these are the examples of the heterogeneous catalyst. Okay. So these examples, please write down, even though it is in a book. If you write it and write down, at least then it will be a practice. Okay. Now we are going to discuss about its theory. We are going to discuss about the modern theory of heterogeneous catalyst. Today's class will be a very small class because I could have finished in last Tuesday, but Tuesday I got so angry with you. Because of that, I stopped taking class. Okay. Modern theory of excuse me. বিপ্লব আমি তো তার সঙ্গে কথা বলতেই ভুলে গেলাম রে সরি সরি আজকে আমি ক্লাস করাম আজকে তারপর তোর নম্বরটা হ্যাঁ modern theory of heterogeneous. heterogeneous. Okay, it is based on absorption. Okay, based on absorption. So you have taken reactants and here you have taken catalyst. Okay, it will be as it is a heterogeneous catalyst. Let us assume that this catalyst is solid. Okay, and you get product. Okay, so let me write it is A plus. All right, and product is A. So what happens? You have taken the reactants, and to that you have added the catalyst. So a catalyst has a surface. So let me draw the surface molecule. So it is like this. Wait, let me do something. If I rub it with alcohol, then it will be clean, but alcohol I don't have so much. I'm using hand sanitizer. So this hand sanitizer I'm using. See, this is the power of alcohol. I think from next month I have to start class 11. So there may be some little change maybe in your routine. Let me see, but I will not disturb you. Okay. So this is the catalyst. So I write now here. It involves a few steps. So let me write here step 1. Okay. So step 1, what will happen? This is the surface of the catalyst. Okay. Now this A plus B will move towards the catalyst. Okay, it will move towards the catalyst. A spontaneous movement of any particle, we call it diffusion. Okay. Once they move, in that case, they will go and settle on it. Initially, it will be physisorption followed by chemisorption. Okay. Okay. So what is going to happen? Say A has settled on it and B has settled on it. Initially, it will be physisorption. See, first the particle has to settle. Initially, they settle by the attraction, and after that, they will develop a bond. Okay. So what is happening now in step 2? Step 2 is adsorption. Okay. Now in step 3, what is going to happen? Step 3, you will find now the molecule are being bonded. So in this process, what is going to happen? The two atoms have now come closer to each other. So now they are going to form a intermediate like this. See, they are going to form an intermediate. That in chemical kinetics I have shown you. They form because chemicals catalyst does take part in the chemical reaction. So this is the intermediate they have formed. That is what has happened. They undergone the reaction. Now after the reaction is over, step 4, what will happen? The product is going to form. When the product is formed, then what is going to happen now? The molecule will detach themselves from the catalyst. That is, they will go away from the surface. When they go away from the surface, what we will call it? Desorption. Now your catalyst has become free. Then step 5 is what? Step 5 is you find the fresh catalyst is here and molecules leave that place. Initially, they alight themselves from the catalyst surface, and finally, what will happen? A plus group AB will move, so that the fresh molecules on A and B comes. So when the molecule moves, so what should we write here? We write here diffusion. Okay, don't worry. You think that you have invited some persons. This is your dining table. So when you request them, they come to the dining table. That is, they move by themselves. In case of the molecules, we call them as diffusion. Then they sit on the chair. Okay, that is, they sit on the chair. So this is called absorption. Then after that, they will take the food. For molecules, we call it reaction. Then they will finish their lunch or dinner. Then they will alight from the chair. Okay, when they stand, there is no connection between them with the dining table and themselves. This, in case of molecule, we call it desorption. Then they go to the sitting room or drawing room and sit. That is, they leave that. This is the modern theory of heterogeneous catalysis. Suppose you forget, remember the first letter. This is the way I try to remember. And I write this. Can you pronounce this one? Huh? Can you pronounce this one? This word? Huh? Try to pronounce.
Dark.
What do you call it? Again, tell me. I could not hear. So, how you are going to pronounce this one? Tell me again.
Dark.
So, have you heard this word earlier?
No, sir.
This type of similar word did you hear earlier? Hello, Grace.
Yes, sir.
What is the meaning of that? If you heard it?
So I'm not so sure. Maybe it is to school.
No.
Teeth.
It is a Urdu word. We call dard means pain. Okay. Suppose you fell down and you got hurt. And if any one person who speaks in Hindi, what you will say? Huh? In Hindi, they call it chot. In Urdu, they will call it dard. And you will go to a doctor. Suppose he doesn't understand Khasi, then you have to tell him both the orthogonal. Try to remember this. Okay. See, when someone scolds, then you feel it is painful. So when you scold, I may feel painful. Huh? Okay. So try to remember. This is simple way to remember this complicated theory. So you know. So this is the you can draw it and explain. Okay. Now we are going to talk about enzyme catalyst. Enzyme catalyst. See, these are biomolecules. These are biomolecules. Mostly they are proteins. And okay, let me tell you something about the characteristics of catalyst. Then I'll go to enzyme. Now, what do you mean by the activity of a catalyst? See, adsorption is a natural phenomenon. On any substance, the adsorption may occur. Especially when you take the transition metals are found to be very, very good catalyst. Okay, but their efficiency depends upon two factors. One is how active is their surface. That is how much they can attract the substances towards them. Okay, so their surface should be very, very active, and they should be able to form the bond also with them. But when the adsorption takes place, if the adsorption is very weak, in this case, what will happen before the reaction between the reactants take place, they may leave the surface. If they leave the surface, then the very few molecules are going to react. All right. So their adsorption should be sufficiently strong. That is, they should have very high effective nuclear charge to attract them, and they should provide them. See, when the formation of bond takes place, bond may occur by two processes. One, each reactant and the catalyst may share electrons. Or second, the reactant may supply both the electrons. If the reactant supplies both the electrons, then the atoms which are present in the catalyst, they must have empty orbitals. When you go to coordination chemistry, you will understand better. Now, second is that their adsorption should not be very strong also. If the adsorption is very strong, in that case, after the formation of the product, they may not leave the surface. If they do not leave the surface, then the other reactant molecules will not be able to come nearer to them. Okay. So we have found that in the transition metal starts from group 3 up to group 12. We find that from group 5 to group 7, these elements which are present, they are found to be very good and effective catalyst because they are they have a strong physisorption. And second thing, whenever they bind with the reactants, their bond are not that strong, so that to withhold the molecules on their surface. Okay, so catalyst, what we do, we generally try to use different substances catalyst, and we try to see how much product is being formed. It is an experimental process. trial and error process, and wherever we find that our yield is very high, only those metals and on or their compounds are being chosen as a catalyst. That is called the activity of a catalyst. Now, selectivity of the catalyst. It is found that if with the same reactants, just by changing the catalyst, you may get different products. So it depends upon that which type of product you want. Accordingly, you are going to use it. Say you might have different types of shoes to go out. Depending upon the occasion and the weather, you select your shoes in that. Okay. Obviously, if it is a rainy one, you are not going to use a velvet shoe. You know that it is going to be spoiled in the rain. If it is very cold, you will not go with a simple type of shoes where your feet will be exposed. Is it not? So same thing is that depending upon the product that you want, we select the catalyst in this way. So I'm just borrowing the example from your book. Take the example of carbon monoxide and hydrogen. Carbon monoxide and hydrogen gives us different types of products because it is the question of reduction of carbon monoxide. All right. Now, if you have used nickel as a catalyst, in that case, you find in presence of nickel, hydrogen is going to reduce the carbon monoxide completely, and you will get here CH4 and water. Now, if you change the catalyst, and if you have used copper in presence of zinc oxide and chromium sesquioxide or chromium 3 oxide. See, CrO3 is chromium trioxide, where oxidation state of chromium is 6. In Cr2O3, the oxidation state of chromium is 3. In that case, in our colloquial chemistry language, this is being called chromium sesquioxide. Okay. But anyway, you will not be able to remember it. Then you only tell the chromium 3 oxide. 3 is the oxidation state. In that case, you are going to get here methanol. This is a very important industrial product. Most of the methanol we prepare by this method. Now, if you have used only the copper as a catalyst, in that case, you'll find you are going to get another industrial important compound. It's called formaldehyde. Okay, formaldehyde. So this is called the selectivity of a catalyst. Selectivity of it. How you select. So obviously, depending upon the product that you want, then you can get it. Same thing. Suppose you want to go for cooking. See, ingredient may be same, but depending upon the spices that you have used, you can prepare different types of curries. But you have started with the same substance. See, by taking chicken, you can make so many different curries, different types of chicken curries, depending upon what type of spices that you use. So it just like that. Okay, that is called the selectivity of a catalyst. Now, we come across a very important type of catalyst. We call it shape selective. Shape selective. Shape selective. In this type of, see, I told you that catalyst provides a surface area for the reactant to adsorb. There are some catalysts where you find there are millions of holes are there. And the holes are being created by them. Let's take the example of okay. So these type of holes are there. Okay. Now it can be two-dimensional, it can be three-dimensional. And these are the holes where you find the reactant molecules and settle in these holes or pores. Okay. Now, depending upon these are called silicates. Silicates. These are naturally available as well as you can make it by yourself. If they're naturally available, we call them as zeolites. You have already studied in school in the purification of water, zeolites are being used. Or it can be made artificially. Zeolites can be two-dimensional, it can be three-dimensional. If it is two-dimensional, it almost looks like a sheet. And three-dimensional of that, though I cannot, need not tell you. Now, in these holes, okay, this you can measure the radius of this hole or diameter of the holes. Okay. Now, in these holes only, these substances come and settle. Now, if the size of your compound which you are reacting, if it fits within this, all right, it can go for this catalysis. But if it is too small, then it will escape, it will go out. And if it is too large, then it cannot go inside that. So that is called the shape selective catalyst. Just like that, when you go for buying a pair of shoes, you go to a shop. Just looking at the shoes, you don't buy. First, you take it and wear it. If it is tight, then you don't go for it. And if it is too loose, then also you don't go for it. It should exactly fit in your feet. So same thing is there in this called uh, this type of these are called shape selective catalysts. Okay, this type of catalysts are generally called somehow in your book. I think they have not mentioned. These are called molecular shapes. This word did you hear earlier? Hello. This word did you see earlier in English? I told you no, don't keep quiet. Other also should tell. This one, have you heard this name? This word earlier?
Yes, sir.
Yes, sir.
What is that?
Strainer.
Strainer. What
Strain.
in Khasi? Khasi, what you call jinker something? Khasi, what you say? You use it for making tea, na?
Yes, sir. We
What
call
you
it
call it?
ginger sha.
Ginger.
Slasha.
Ginger. Ah, yes. Ginger sha. See, now suppose you want to clean the maida flour in your house. And if you want to clean the atta, mind it, both of them are different. Because the grains of atta is larger than that of maida. So if you go for that ginger sha of which by which you clean your maida, sorry, atta, if you do go for your maida, what will happen? Everything will fall. Okay. So these are called molecular shapes because these holes are just like the sheep that you use or strainer. Okay. Molecular shapes. And molecular shapes are numbered like this. Hmm. It is being numbered like this: 1 angstrom, 2 angstrom, 3 angstrom, like this. Suppose if you work in research laboratory, later on you'll find these are what are these. You know what is the angstrom? Is 10 to the power what? -8 na centimeter, -8 or -7 angstrom. I think that was a -7. So these are the dimension of their holes. Okay, these molecular shapes are very important catalysts, and they are being largely used in petroleum industry. Okay, a very important this shape selective catalyst called ZSM5 is being used in petroleum industry. If you heat ethanol with this, they convert ethanol into petrol. Now, what is this ZSM? Z stands for zeolite here, and S stands for ship, and this is called molecular. And this 5 is nothing but the diameter of their hole. This is very important. This is given in your book also. Please remember for your school exam. The ZSM5 is being profusely used in petroleum industry, which converts ethanol to petrol. Okay, now we go for the enzyme. Enzyme, I told you these are biomolecules. Okay, biomolecules which helps in the expedition of the different chemical conversions. It can be a biochemical reaction, or it can be a normal reaction also. And these type of catalysts are extremely specific. I told you that enzyme, most of the enzyme catalysts are made of proteins, but there are few which are non-proteinous also, which are non-proteinous. So they are extremely selective in their chemical activity. They are going to catalyze only one specific type of reaction, and if the reaction is finished, then they'll remain dormant for years together. They will not carry out any other chemical reaction. Due to that, you will find this type of catalysts are generally named after the reactant on which they react, or the process of the reaction they carry out. See here, take the example of sugar. See, in nature, sugar is not being hydrolyzed by acid. That we do in our laboratory or at kitchen. In this case, you will find they get hydrolyzed to give you glucose and fructose. This process you can expedite by 1,000 times than that of using sulfuric acid or HCl by using a enzyme. This enzyme was previously known as invertase, but these days we do not call it invertase, we call it sucrase. Why? Because it acts only with the sucrose. It will not going to carry out any other reaction. Okay, now see. I have a similar compound. This is same molecular formula. It is called maltose. Maltose also undergoes hydrolysis to give you 2 units of glucose. But in this case, sucrase cannot carry out the hydrolysis of, cannot catalyze the hydrolysis of maltose. For that, you have to use a specific enzyme called maltase. reductase. See, if you go to an urinal, you get a strong smell of ammonia. Okay, but human urine does not contain ammonia. Then where from it comes? See, it contains urea. In your toilet, this enzyme grows by automatically. It does the hydrolysis to give you 2 molecules of ammonia and carbon dioxide. Okay, you know who does this? Who helps this hydrolysis? For an enzyme called urease. You have seen, suppose you concentrate the milk that you have in your house and you can put little bit of old curd, okay, and you leave it overnight. What you get? You get curd or not? You get curd. How do you get curd? That is also by an enzyme. It's called lactobacillus. So this is also an enzyme, lactobacillus, and is being given by a bacteria called lactobacillus bacteria. So these are all the types of enzyme, and most of them you'll find is being named after the reactant on which they operate. Suppose you'll find there are some enzyme who helps in oxidation. Then after the name of the enzyme, you'll find it is written that oxidase. Those who are having biology, you know much better than me. If we carry out reduction, you'll find it is written the reductase. Millions of such enzymes are available in the nature, and they are very, very specific about it. All right. So let us know the characteristics of enzyme. What is the characteristics? It is nicely written in your book. Characteristics of okay. These are extremely efficient. See, one molecule can catalyze 1 million molecule of reactant. See, human being boasts, but we could not make any catalyst of this efficiency. Okay. Because of that, you require a very small amount of the enzyme catalyst. So you require extremely small amount. See, when you go for baking, why do you do not use yeast? Such small amount of yeast you use. Yeast is the source of all enzymes. Okay, see, it does a magic. Extremely small amount is required. Why it requires such a small amount? See, it's conversion. Look, it is a conversion. 1:1 million, 1:10 to the power 6. So in that case, obviously, you don't require so much amount of the substance. It is highly specific in nature. I already told you, highly specific. That is, one enzyme is going to catalyze only one specific reaction. It will not catalyze any other reactions. Highly specific in nature. Okay. Highly active under optimum pH. All right. It is highly active within 5 to 7 pH. If the pH is lower than that, enzyme activity will decrease. If the pH is higher than that, enzyme activity will decrease. I give you a simple reason. Not simple reason. I'll give you a very simple example. Say, suppose you are feeling little feverish. Then you find, now, suppose you have developed some acidity. So in that case, your mother will tell you, don't take any spicy food, take only boiled substance. Why? When you have developed acidity, the pH of our intestine goes down to 4 or below 4. Now the enzyme which helps you in digestion, this enzyme is not going to function well. And you'll find you have developed vomiting tendency or your stomach will be upset. All right. Now, highly active under optimum temperature. Okay. See, it is goes for a for very efficient activity between 298 to 300 Kelvin. Okay. 310 Kelvin is what? If I subtract 310 minus 273, how much it comes? It comes to 37.
Body temperature.
37 degrees Celsius. 37 degrees Celsius. That is the normal human body temperature. Okay. So I was about to tell you that when you develop fever, why do you lose your appetite? Because the body temperature is not 37, is more than that. Then the enzyme which helps you in digestion, they become ineffective. All right. So now, my advice. Many of you have a habit of taking too much of fruit drinks or fruit juice or the carbonated water. Okay, suppose it is warm, then you drink Coca-Cola, this and that. Do not drink so much. Because when you mix carbon dioxide in water, carbon dioxide undergo association with water molecules with form carbonic acid. By that way, it reduces your pH of your intestine. Carbonic acid is there. Then you lose appetite. Why? Because by that way, many enzymes are get killed. Many a time you'll find, suppose you are having high fever or you have stomach upset or maybe other something, your doctor has given you antibiotic. You'll find that you have become all right. But after that, your stomach problem starts. Either you lose, see, after by taking antibiotic, why do you lose appetite? You develop a vomiting tendency because in our body, you are having good bacteria and bad bacteria also. Bad bacteria has made you sick, but you have good bacteria in the form of lactobacillus bacteria. But antibiotic kills both good and bad bacteria. As the flora of the lactobacilli bacteria in your body has gone down, it is now producing very less amount of the lactobacilli bacteria to help you in digestion. In that case, your digestion process does not function well. I remember in our childhood when you have stomach problem, my mother used to give me curd rice. You know why? Just now you have seen curd contains what? Curd contains huge amount of lactobacilli bacteria. She was not a student of science. She has learned from generations, from the elders. Okay. So these days, of course, doctor will prescribe you along with this antibiotic, probiotic also. Probiotic capsule, you please read this. You are a science student. Whenever you take any medicine, please read the composition. In probiotic cases, you will find it is written there. It contains spores of lactobacilli bacteria, which supplies you lactobacilli enzyme. Okay. So just like that, in case of the normal catalyst, I have talked about the promoter and the catalytic poison. In case of enzyme, also such things are there. In enzyme, see, enzyme is containing the promoters and activators. Promoters in the form of some organic molecules, which you call them as coenzymes. When the coenzymes are present along with the enzymes, the activity of the enzymes are enhanced. Most of the coenzymes are nothing but vitamins. So when you fall sick, along with the medicine, doctor also gives you vitamins. These vitamins are given to reactivate the enzyme that is helpful for your body. Okay, so these are the promoters. Then there are some metals are there, or metal ions are there, which helps in the activity of catalyst. These are called activators. They are they bind to the enzyme and they enhance the activity of the metals. Okay, these are mainly sodium, manganese, cobalt, and copper. So where from you will get these metals? You will get these metals from the vegetables. I found these days there is a fashion is there that you people take less vegetables and more you go for the non-veg. Okay, please remember the proteins which are available in the vegetables are easily digestible than that of the enzymes which are there in the non-veg. Okay, so this should be supplied. These are all being supplied by the vegetables. So they enhances the activity of the enzymes. Now you have the catalytic poisons are there. Okay. So in case of the enzymes, we do not call them as catalytic poison. We call them as inhibitors and poisons. Inhibitors and poisons. Now I have already showed you where the heterogeneous catalyst is. By the same way, I'm going to show you the mechanism of the enzyme catalyst. You will find these substances which they are supposed to react. If these places are being blocked by some other foreign elements, then what happens? The catalyst become ineffective. So those ions which inhibit the catalytic activity of the enzyme catalyst are known as catalytic poison or catalytic poison or inhibitors. Say, take the example. Suppose if you make a curry and if you take it fresh, no problems. But if you keep it exposed, not in the fridge also, keep it exposed for maybe 24 hours or 48 hours. If you take the same curry, whether it is a vegetable or non-veg, in that case you find that you have developed stomach problem. Sometimes it will be very serious. Sometimes it leads to death also. Why it has happened? Because the protein which is found to be nutritious for us, when you expose it, some of the microbes, they break the protein chain into smaller fragments. They oxidize it, and those smaller fragments are found to be extremely harmful for us, and that leads to the food poisoning. Why? Because the enzyme which has helped us to digest the food, all these enzymes are now being the the structure is being destroyed by this type of proteins, or they bind with the enzymes. In that case, entire activity of the catalyst gets spoiled. Okay, now we'll go for the mechanism of enzyme activity. Mechanism of enzyme. Mechanism of enzyme catalysis. See, enzymes are made of proteins. Proteins are made of amino acids. In amino acids, you have functional group like carboxylic acid, NH2, SH, OH. These type of groups are there. These groups are the active sites where we will find your chemical substances or biochemical substance they bind. These are called the active sites. Enzymes are proteins, they have a fixed three-dimensional geometry. So the substrate should be able to cope up with the shape of the enzyme. If the substrate shape is almost equivalent to the shape of the enzyme, then it will fit. Otherwise, it will not fit. Say you and your sister have the same number of shoes. Say your size is 5 and her size is 5. But the shape of her feet may not be same as the shape of your feet. In case of emergency, if you wear her shoe, you will feel uncomfortable because her feet pattern is different. So the shoe has taken the shape of her feet. She will be comfortable, but you will not be comfortable. So there are two theories by which you can discuss the enzyme catalysis. One is called lock and key model. One is called lock and key model. And second one is beyond your discussion. It is called induced fit model. We are going to discuss this one. Lock and fit. See here. So, step one. Suppose this is the enzyme. I'm very bad in drawing. Okay. So this is the enzyme. And this is the reaction. So when they come nearer to each other, see these are the active sites where they find, and the geometry is matching. So they are going to form a complex called EX. All right. In step 2, what will happen? You'll find don't laugh at my drawing, huh? See here. Now, see, they are separated. So this is called, from this is the step. So ES will become now EP. And finally, see, the product will separate. So now this is the way they have. So why do you call it lock and key model? We know that every specific lock has a specific key. Similarly, any substrate whose structures matches with this one, they only then this enzyme is going to react or catalyze, otherwise they will not. So because of this model is called lock and key model. Thank you. So from next Saturday, I finish physical chemistry part. Next Saturday, we'll start inorganic. Is very big. I'll try to see how much I can do. Thank you.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Thank you, sir.
And last class, I have told you also that many of you did not pay for June, July, and some of you did not pay for June. Please clear your fees, because every now and then I need not like to tell you all about this. Okay then. Bye. Good night.